Welcome to Homework Lib.
Chapter 14, question 106. The following is a quote from an article from in the August 18th, 1998, issued in the New York Times. And a drop of 18 degrees Fahrenheit from 77 to 59 lowers the reaction rate six times. A 36-degree drop from 77 to 41 Fahrenheit produces a 40-fold decrease in the rate. So they want us to calculate the activation energies for the breakdowns for these two different drops and compare them to see if they're consistent or not. So first of all, what we need to do is to convert Fahrenheit to Kelvin. The conversion factor will be Fahrenheit minus 32 times 5 over 9 plus 273. So 77 degrees is going to be equal to 298 Kelvin, and 59 is going to be 288 Kelvin. Now, if I use the formula ln K1 over K2 equals to energy of activation divided by 8.314 times, in the parentheses, 1 over 298 minus 1 over 288. You call this guy is going to be 1 over T2, and this guy is going to be 1 over T1. And this part is going to be equal to, since it says 6 times, it's going to be 1 over 6. So just remember that for which K we assign which T. For K1, we assign the the smaller temperature, which is going to be 288. So that's why this is a T1. And for K2, we assign the higher temperature. So if you solve for EA, you're going to get the result 100. Oh, it's not 100. It's 127,849.337. Now, at the second, we want to do the 40-fold. So over here, 41 Fahrenheit would be equal to 278 Kelvin. So as you can see, it's just dropping 10 drops from here and 10 drops from there. ln, in the parentheses, K1 over K2. Now, this is going to be 1 over 40, and this will be equal to EA over 8.314 times 1 over 298. This is going to be our 1 over T2 value, which is corresponding to the higher value over here, the 40, minus 1 over 278. And this is going to be our 1 over T1 value, which is corresponding to 1 over here. So if we solve for EA, what we're going to get is 127,038. So if you compare these two values, these are joules per moles. This is also joules per moles. And if I convert that to kilojoules, then only after the first decimal we see a difference. So we can say they're pretty much consistent with each other. At part B, they're saying assuming the value of EA calculated from 36-degree drop for Fahrenheit, which is 20-degree drop from Kelvin, from 298 to 278. So we're going to use this value as EA. And the rate of breakdown is first order with a half-life is at 25 Celsius, 2.7. So 25 Celsius plus 273 equals to 298 Kelvin. The second value is minus 15 Celsius plus 273 is going to be equal to 258 Kelvin. Now, if I write the same equation, let's use green this time, ln K1 over K2 equals to 127,038 divided by 8.314 in the parentheses 1 over 258 minus 1 over 298. Now I'm using this as 1 over T2, which is going to correspond to K2, and I'm using this as 1 over T1, which is going to correspond to K1. So what we find from this equation is K1 over K2 equals to 2,834.6. Now, if you recall the formula for first order reactions half-life, 0.693 divided by K would be equal to the half-life. So for our first case, we can just use 2.7 year, but you need to be aware if our unit is year for the first one, the second one is also going to be the year. So from here, if we just substitute T with 2.7 and substitute K with this value, solve for K2, our T for K2, half-life for K2, is going to become 7,653.42 years. Again, this value is corresponding to K2's half-life.